Okay, year 12s. Now let's have a look at the second example. But before we can go into the second example, there are just three more things that I want to quickly show you. Okay, so there are three situations which we need to watch out for when using the change of sign rule to locate roots. A change of sign does not necessarily mean that there is exactly one root, as I explained in the previous video. And the absence of a sign change doesn't necessarily mean that a root does not exist in the interval. Okay, now let me just explain what I mean by that. So we could have this situation, which I briefly mentioned in our previous video. Now in this situation, let's say we've got a function and our a is here and our b is here. Now at a my function is positive, at b my function is a negative, my y value is a negative value, and in between a and b I've actually got 1, 2, 3 roots, so I've got odd number of roots. Okay, so even though there is a sign change, in the interval AB, there are 3 roots. Between the interval AB. Okay? Now in the next scenario, you could have something like this. So you've got a negative quadratic, you've got A here, and let's say you've got B here. Now at x is equal to a, my value of the function is negative. At x is equal to b, the value of the function is negative as well. So there is no sign change here, but that doesn't mean that there are no roots. There is no sign change between the interval a and b, but there are actually 2 roots. Okay? So we've got to be careful of this situation. So we can say there are multiple roots within the interval AB, but a sign change does not occur. So we have an even number of roots, and here we had odd number of roots. Okay, now these 2 examples are for continuous function. Okay, and what that means is that I'm able to draw this function without taking the pen off the paper. Okay, now in the third situation, I could have, and this is where I was talking about the reciprocal function. So you could have something that looks like this. And what did we say that this function was? A discontinuous function. And the reason for that is that I can't draw this function without taking the pen off the paper. I've got to do this, take pen off the paper, and then draw this section of the function. Now here what happens is that yes, I do have a sign change between A and B. Yes. So at A, positive, B, negative. But there is no root between the interval A and B. Okay, so we've got to be careful about these scenarios. So we can say that there is a vertical asymptote within the interval AB, but a sign change does occur, but there is no root. Okay, and now let's look at example 2. Okay, so in example 2, I've got a graph that's been given to us, okay, and what it says is that the graph of the function f of x 54 x cubed minus 225 x squared. Let me write that down. So I've got f of x equals 54 x cubed minus 225 x squared plus 309x minus 140, and that's shown in the diagram. And the diagram, now this is on page 275, and the diagram looks something like this. Okay, just going to draw a really quick sketch of it. Where this is 1 and this is 2. And what it says is, a student observes that f of 1.1 and f of 1.6 are both negative, and states that f of x has no roots in the interval 1.1 and 1.6. Between 1.1 and 1.6. Okay, now we need to explain by reference to the diagram why the student is incorrect. So by reference to the diagram, we can clearly see that there are at least, well, there is at least one or possibly two roots between that interval. Okay, so we just need to write that down. Whenever it says refer to the diagram, or then if a diagram is given and we can refer to it, we should. But when it says show that or calculate, then we actually have to show our working. Okay, so the diagram shows that there could be two roots in the interval 1.1 to 1.6. Okay? Part B, the question says calculate f of 1.3 and f of 1.5 and use your answer to explain why there are at least three roots. So we need to explain that there are at least three roots in this interval 1.1. Now look, they use a different notation. They are not using the bracket notation here. They've gone back to inequality. So what that tells us is that we need to know what both the notations actually mean. Okay, and this is not to be confused with a coordinate. Okay, although obviously it looks exactly like a coordinate, but in this context it is actually an interval. Okay, so what we're going to do is we are now going to work out the values of the function at 1.1, 1.3, 1.5 and 1.7. so the endpoints and these two values. We're going to work them out, and then we will show that there could at least be 3 roots in this interval. So if I was to substitute 1.1 into my original function, if I sub that in the calculator, I would get minus 0.476. That's a negative. If I substitute 1.3, I'm going to get positive value. If I substitute 1.5, I'm going to get another negative value. And if I substitute 1.7 into my function, then I'll get a positive value. So that's positive, negative, positive, and this was negative. So a negative to a positive, that means there's one root. Positive to a negative, another root. And negative to a positive, another root. Okay, so as there is a sign change between 1.1, 1.3, 1.3, 1.5, 1.5, 1.7, there are at least 3 roots in the interval. And now you are going to use the notation that they are using in the question. Although you're not going to lose marks if you use the bracket notation, but if they have given a notation in the question, it's always best to use their notation for your final answer. Okay, so that's example 2.